So we are discussing new topic, potential difference between 2 points in electric field. This is the electric field region. There are 2 points, point A and point B, and let us say potential at the point A is VA and potential at the point B is VB. I take a charge Q at point A and I shift this charge Q from point A to point B. I think all of you know that work done does not depend on the path because it is conservative force field. So if I say I calculate the interaction energy of charge Q at point A, what you will say? At point A, interaction energy of any charge Q can be written as Q into potential at that point. Similarly, when charge Q is placed at point B, interaction energy or potential energy at B can be written as Q into potential of point B. Now, if I ask you calculate the work done in shifting the charge from point A to point B, you will say external work done is final interaction energy minus initial interaction energy, and you will calculate it will be Q into VB minus VA. VB minus VA is potential difference between point B and A. So what is VB minus VA? You will say VB minus VA is work done in moving from A to B per unit charge. So always you will say in an electric field potential difference between 2 points is defined as work done in shifting a unit positive charge from one point to another point. Let me show in the next slide. All of you just read it and try to understand it. Again I am explaining each and everything which I have discussed just now. This is your basic formula, and potential difference is negative of the work done by the electric field, because I think all of you know work done by the external field plus internal field should be equal to 0, and we are taking for the external field. So if it is work done by the internal field or electric field, it should be minus. Now I am asking you a simple question. Try to solve it. This red color proton is placed between two parallel conducting plates in vacuum as shown. The potential difference between the two plates is 450 volt. You can say this is the plate number, positive plate is 1 number, I say like this, and negative is 2 number. And it is given that V1 minus V2 is 450 volt. The proton is released from rest and initial kinetic energy is 0 to the positive plate, like this. Question is that what is the kinetic energy of the proton when it reaches the negative plate? All of you know delta K plus delta U should be 0. That you people know very well. Let me explain. Initial kinetic energy is 0. Delta U you can calculate because you know the formula V equal to U by Q. So delta V equal to delta U by Q. Delta V is given to you, Q is given to you, delta U you can easily calculate, that is Q delta V. And negative of that will be the change in kinetic energy, delta K. So please try to solve. I am showing you in slides. This is in electron volt. Sometimes you have to convert into joule also. So I hope you people know very well. You have to multiply by 1.6 into 10 raised to the power minus 19, like this. One more question I am asking you. Find the work done by the external force and electrostatic force. One thing is clear to you, sum of work done by the external force plus internal force should be 0. Now if question comes work done by the external force, again I am repeating, all of you know you will use this formula UF minus UI, and work done by the internal force, all of you know you will say UI minus UF, because both are equal but in opposite. I hope you will get this. So minus will be omitted here. Please read the last line because I have discussed it a lot. Okay. If we let go a positive point charge from rest in uniform electric field, what will happen to the potential energy of the system? Just you think, if it is the earth and any object of mass m is here, same thing, like the positive point charge always resemble with the gravity. If you let this object to go from rest, all of you intelligent, this will move toward this side. What is happening? The potential energy decreasing. Yes. Similarly here also you will say positive charge move in the direction of the electric field, force and displacement are in the same direction. Cos 0 degree equal to 1 and work done is positive, and I have discussed earlier, whenever the work done is positive, potential energy will decrease. Okay, lightning. This phenomena you have seen in your daily life. I am showing you in the video clip, just listen it.